Good morning. It's me, Mr. Lazenby, trying something new. We're going to try and do a video lesson. Today we're going to talk about polynomial multiplication and binomial expansion. We have two objectives we would like to learn today. The first one is we want to be able to multiply any number of polynomials together. Our second objective is to be able to use Pascal's triangle to expand any binomial raised to the power of a positive integer. Now, I know this is the first time y'all have seen me do a video lesson, but let me give you some advice. First, you're watching this on your own typically, so if you need to see something again, just pause it and rewind it a little bit. Take your time until you understand, and I want you to come back to class tomorrow with any questions you have. Right. First is polynomial multiplication. There's a couple of basic rules. First, every term in each polynomial expression must be multiplied by each term in any other polynomial expression. Here's an example. X plus 3 times x plus 4 times x plus 5. Right, the first thing I'm going to do, I want to multiply x plus 3 times x plus 4 and get a quantity for that. So you can see I'm going to multiply this x times both the x and the positive 4. I get an x squared and a 4x. Then I'm going to multiply the plus 3 times the same x and the plus 4, and I'll get a positive 3x, a positive 12, and then I just need to combine the like terms. That's where I got the x squared plus 7x plus 12. But I'm not finished, because if you remember, I needed to multiply this times x plus 5 as well. Well, I've already put it down here. Now we just got to do it again. So we're going to repeat steps 1 and 2. Now I've got the x squared plus 7x plus 12 here, the x plus 5 on this side, and I need to multiply out. X times x squared is x cubed, x times 7x is 7x squared, x times 12 is 12x. Same thing with the plus 5. Plus 5 times x squared is 5x squared. 5 times 7x is 35x. 5 times 12 is 60. Then I combine like terms again, and I have my final answer. Alright, feel free to pause now if you need to check the work and see what's going on. If not, I'm going to continue. Now, there are other methods of multiplication. You don't have to use the boxes like I do. You can do vertical multiplication, which is what you learned back in 3rd and 4th grade, where you line them up one on top of the other. First you'd multiply the 4 times x plus 3. That gets us 4x plus 12. Then you're going to come back and multiply x times x plus 3. Try and line them up as best you can. Now combine like terms. You have your answer. X squared plus 7x plus 12. You also can do horizontal multiplication. This should remind you of the FOIL method. Again, you have to multiply each term times every term in the other expression. So x times x plus 4 gives me x squared plus 4x. I'm going to come back and do the same thing with the 3. 3 times x plus 4 gives me 3x plus 12. Combine like terms, and I've got x squared plus 7x plus 12. The same answer we got here. Your method does not matter as long as you come up with the right answer. That's all you need to know about methods of multiplication. Now let's talk about binomial expansion. What binomial expansion is talking about, it's about raising a binomial, any binomial, to a positive integer. Now this is the old-fashioned way, where you're just going to have to multiply time and time again until you get to the answer you're looking for. Well, for x plus y to a 0 power, and that's easy. Anything to a 0 power is 1. Well, to the first power, still easy. Anything to the first power is itself. Alright, now we're going to square. We actually have to do some multiplication. Alright, this is it in expanded form. This is what you're actually doing. This is what you come up with for an answer. Now when we come down to the third, again it's expanded form, but basically we have to take x squared, or x plus y squared here, multiply by x plus y to get this. And then again to do the fourth power, and then the fifth. So you've got to do all this work here just to get down to that answer there for a binomial expansion. That's a lot of work, and like I've told you before, mathematicians, they don't want to use the word lazy, but they want to be efficient. They want to do as little work and get the good results. So that's what we're going to look at next. You want to get this down. This is binomial expansion. Get these rules down. You're going to need them. It's going to make your life easier for the next couple of days. First, we're going to use Pascal's triangle. That's the triangle we filled out the other day to expand x plus y to the nth power. The first thing you need to do is find this exponent n. Alright, second, look at your Pascal's triangle and find the row that uses n as the second term. That's the row you want to get. The numbers in that row are the coefficients of each term. Alright, those are the numbers that you're going to have in front of your variables. Alright, now here's a little bit to tell you about what those variables are going to look like. The first variable will start out with the exponent n. So here, your first variable is x. Your first term should have an x to the nth power. Alright, the second variable starts with an exponent of 0. So it would be y to the 0, which is just 1, so you're not even going to see the y. Now, once you move on to the next term, that first variable's exponent decreases by 1. And the second variables will increase by 1 all until you get to the other end where your x has disappeared and you've got y to the nth. One way you can always check that, those exponents should add up to whatever the value of n is. The last thing you need to do, say you get a binomial where it's not x plus y. Well, once you get down to the end, just plug in whatever that real value was instead of x plus y, or x or y, and then you just simplify it. I'll show you an example on the next slide, and hopefully that'll take care of it. Right. Using Pascal's triangle for binomial expansion. X plus y to the nth power. Alright, here's our example. X plus 3 to the 6th. Alright, first thing we got to do is figure out what the exponent was. It was 6, so we want to go to the row that has 6 as the second term. That's this row here. Alright, so these are the coefficients that we're going to use. 1, 6, 15, 20, 15, 6, and 1. Now notice my exponents. X was my first, and it was x to the nth power. Then I went down 1 for it, down to a 5, and my y went up 1. Down again for x to the 4th, up for y to the 2nd, down and up again, and again, and again, until I get y to the 6th. Well, x is not there, so it's got to be x to the 0 power, which is 1. Alright, now, we didn't have x plus y, we had x plus 3. So any place there's a y, I'm going to substitute in a 3, which is what I've done here. Alright, and now all I got to do is simplify it. I got to work out all those 3's to whatever power they are and multiply. That's where I got this. If I were y'all, I'd pause this and look over it. Make sure you understand it, because this is it. This is all we've got. And we're done. Right. Thank you for your time.